Dear students, today we are going to discuss the difference between the mass and weight. So the comparison only. So let's see this table. The left side mass is there, the right side is weight. So the first one, the definition for the mass. Actually, the mass is the properties of matter. The mass of object is the same everywhere. For example, let us take any object. Okay. So in this object, the number of particles contained in the body. Okay. So that is known as mass. Let's come to the right side, that is a weight. Weight depends on the effect on the gravity. Weight varies according to the location. So actually the weight means, already mass. Number of particles contained in the body, that is mass. So each and every mass is affected with the gravity, it is called as weight. Okay. If the mass is constant everywhere, but the weight varies place to place. Let us imagine our earth also. In that earth, so let us consider two different regions. One is equator and then poles. So if you focus that equator, here having gravity value is different. But in the poles, gravity value is different. On the surface of the sea level, gravity value is different. Actually, that is exact value. Okay, so place to place, the gravity value is varying. Even let's take that moon. The moon's gravity is 1/6 times is reduced comparing with the earth. So it is not constant. So if the gravity value is changing, then weight value also changing. Right. See the second one, mass can never be zero. Mass will not zero. Mass attains some value is there. But weight can be zero. That is the second one. Weight can be zero if no gravity act upon an object as in space. So they mention one example is space. So in the space, if there is no gravity means, so there is no gravity, so the weight is zero. Even the center of the earth also, the gravity value is zero. So weight is zero. And then third point, mass does not change according to location. So this is same point only. Mass does not change, okay, with respect to location. So wherever you go, the mass will be the same. Okay, if you take one pen, the piece of pen, so its mass is for example 100 gram. Wherever you go, that mass is 100 gram only, but weight value will be changed. So see the right side, weight may be increasing or decreasing, okay, with respect to the gravity. If the gravity value is high, weight also increasing. If the gravity value is low, so weight also decreasing. Okay. Next, fourth point, mass is a scalar quantity. It has magnitude. Yes, of course. 100 gram, 1 kilo, 2 kilo. Okay, so this is only that. It is only that magnitude only. So only magnitude means that quantity, that kind of physical quantity we called as that is scalar quantity. Only the magnitude, there is no direction. But if you see that weight is a vector quantity. Vector quantity, it having magnitude as well as direction also. So that only I mentioned here. It has magnitude and is directed towards the center of the earth. That is very important point. Because the weight, okay, weight is nothing but mass into gravity. Gravity always towards the center of the earth. That only they mention here. Next, see that the fifth point, mass may be measured using the ordinary balance. So that you can go to the jewel shop, we can see that balance, that is a physical balance. Nowadays they are using that digital. Okay, or if you go to that physics laboratory, we can see that physical balance. Okay, so that is used for to measure the mass of the body. But if you go to that chicken shop and then old paper market and something, so we can see that spring balance which is used to measure the weight of the object. Okay, right. Next question, point number 6. Mass usually measured in gram and kilogram. If it is SI unit means that is gram. Okay, CGS unit means that is gram, and the SI unit means that is kilogram. Okay, right. So you know very well 1 kilogram is nothing but how much gram? Yes, 1000 gram. Okay, fine. Next, the right side, weight is often measured in the Newton, in the newtons, a unit of force. Newton, the unit of force. Okay, so we can say that one more idea. Generally, the weight is, we can measure it as the kilogram weight, or otherwise we can see it in the Newton. Okay, 1 kilogram weight is equal to 9.8 Newton. Please be in mind, it is very important point. And the next one, the mass unit is in kilogram. That is specifically SI unit only I write as a 7th point. Mass unit is in kilogram, and then weight unit is in Newton. So weight formula. So the mass simply represented by, that is a mass, that is M. Okay, and then weight, that is W. So W is equal to mg. You know, M into G. G is nothing but acceleration due to gravity. M is nothing but mass. So mass into acceleration due to gravity. It is like F is equal to ma. So only the force unit is Newton also we can use it for the weight. So weight unit also Newton. Okay, so this is the difference between the mass and weight. So we recapitulate one more time. Okay, the mass is constant everywhere, but weight will be vary place to place. And then mass is nothing but number of particles contained in the body, but weight is each and every particle affected with the gravity. And then mass can never be 0. Okay, but weight possible to become 0. Okay, with respect to the gravity. If the gravity value is 0, the weight also 0. And then mass value does not change according to the location. Wherever you go, mass value will be the same. But weight value is not like that. If the gravity is increasing, weight also increasing. If the gravity is reducing, weight also reducing. Next, 4th point, mass is a scalar quantity. Okay, because it has only the magnitude. But weight is a vector quantity. It has magnitude as well as direction. What is the direction? It is always towards the earth. Just you take one object, just you leave it, what will happen? It will move out of the earth or towards the earth. It is towards the earth. So it is having certain direction also. Okay, so weight is a vector quantity. Next, 5th point, mass may be measured using the ordinary balance, that is a physical balance. Physical balance has one more name, that is beam balance. Okay, but weight is by using the spring balance. Weight can be measured by using spring balance. And then 6th one, mass usually measured in gram, that is in CGS unit, kilogram in SI unit. Okay, and then the weight we can say kilogram weight, otherwise one more unit is Newton. Okay, so 1 kilogram weight is equal to 9.8 newtons. That is very important point. And then the next one, the SI unit of, specifically SI unit for mass is kilogram, and then weight is Newton. Then specific formula for weight, that is W is equal to mg. Okay, students, this is very important comparison between mass and weight. I hope you understand. So please take the notes. It is very important. Okay, thank you.